let's start. So with the parking meter problem, so you have a problem that says a parking meter filled with $4.50 in dimes and quarters contains twice as many dimes as quarters. So you know that if I had 8 quarters, right? How many dollars would that give me?
2.
2. Because what did you really do? If I had 8 quarters, you really said 0.25, right? Because 25 cents times Q gives me, which was 8, gives me $2, right? So let's do that the same way. So you have 0.25, all right? And then you have times Q, right? We don't know that value. And then we have plus 0.1 times the number of dimes is going to equal what? $4.50. All right, so now so if I have this 0.25 Q plus 0.1 dime is equal to $4.50. Well, that's not really fully the whole equation. What we really need to do is understand the relationship between dimes and quarters. So we know that there are twice as many dimes as there are quarters. So we have Q. So there's twice as many dimes. So what we're really gonna have is Q equaling 2D. So so when we rewrite the equation, we're gonna have 0.25 D, because we're gonna put that in, plus 0.1 times 2D, okay, is equal to $4.50. So we have 0.25 times D plus 0.1 times 2D equals $4.50. We now have, we're going to take that, we're going to have 0.25 D plus 0.2D equals $4.50. Does everyone understand how we changed the Q to D? So we had originally 0.25 quarters plus 0.1 dimes is equal to $4.50. But we realized, well, we have to make dimes and quarters the same variable. So we said 0.25. We knew that there were twice as many dimes as there were quarters. So we do D in terms, because D is going to equal really the number of coins rather than the value of the coins. Okay? So if you're a little confused, right, you might want to use a different variable. Okay? So let's forget for a minute quarters versus dimes. Let's say we're just talking about purely understanding that there are going to be 2 coins. Okay? We know the value of a quarter is 25 cents. So let's call that 0.25. Okay? And let's say the value, there's going to be X. There's going to be X quarters. All right? So 0.25X plus, well, how many coins are there? How many more dimes than there are quarters?
2.
So there's 2 times as many. So we have 0.1. So we have 0.25 times X. All right. And then we have 0.1 times 2x. Well, why is it 2x?
Twice as much. Because they're twice as much diamonds, they're all quarters.
Perfect. And the total is going to equal $4.50. Okay, so you have 0.25x plus 0.1 times 2x is equal to $4.50. And then what I'm going to do is I'm going to multiply, or I'm going to solve this equation. So 0.25 times x, and then I have 0.1 times 2x. That's going to be, if I multiply the 0.1 times 2x, I'm going to get 0.2x. So if I have 0.25 plus 0.2x, sorry, 0.25x plus 0.2x is equal to $4.50. Then, all right, and if you want to see my work, oh, I did it right there. Let me see if I can flip the screen. Nope, can't flip the screen. But if you want to see my work, I did it right there. I don't know if you can see that. But essentially, I have 0.25 times, plus 0.2x equals $4.50. If I add those together, combine my like terms, I'll get 0.45x is equal to $4.50. I'm going to divide by 0.45, divide by 0.45. I'm going to get x is equal to 10. So if there's 10 quarters, all right, there's 10 quarters, that's going to give me $2.50. Right? Does everybody get why that's going to give me $2.50? Because 0.25 times x, the number of quarters, is equal to $2.50. So that's the first one. All right, so we have column A versus column B. You're going to know that the total value of quarters is going to be less than column B. Okay, so I have 0.25 times 10 equals $2.50. Okay, so I know that column B is greater. Okay, so the next question. I know that one's a little bit harder, but hopefully got a little bit better of our understanding. Did we feel good about the inclusive question last time? You said, I did. You said so. Okay. So we don't. So give me a thumbs down if I need to go over the inclusive question again. Okay. So in the inclusive question, we have if the sum of all integers from 1 to 1,000 inclusive is x, then which expression represents the sum to 1 to 998 inclusive? Okay, so let's think about this for a second. If I was talking about the sum from 1 to 10, right? If I was talking about, or let's make it even simpler, 1 to 5, and I was calling that x, I would have 1, 2, 3, 4, 5. Okay? And let me write this here so you guys can see 3, 4, and 5. So if I had it like this, right? Mm-hmm. All right. Oh, also, can someone invite Giovanni on here? I don't know if if you guys are friends with her. So you hit the plus. Cause give me 1 second.
I didn't mean to. Oh, dang, I blocked it wrong. How you do this?
Okay. Giovanni, invite to the room. Okay. Did that. Okay. So, I did it. Don't worry. So we have 1, 2, 3, 4, 5 versus, and then we have, if I said, well, the sum of 1 to 3 is going to be 1, 2, and 3. Well, what are the only numbers missing then? If I have, so what are the only numbers missing?
4 and 5.
4 and 5. So if this is equal to x, okay?
I invite Angel too.
Okay, great. So if that's equal to x, then what's this one going to be equal to? So because the 1, 2, and 3 are crossed out, right? So that's going to be x. Well, what's left? There's only 4 and 5, and that's going to give me what? X minus 9. So now we have x minus 9 because we're going from a bigger number to a smaller number, right? So that's, if I have this, I'll have 1, 2, 3 cancels out, and then I have these two left. Well, this big one is equal to x. The smaller one is equal to, well, I don't know. So but I do know that it's 9 less than the bigger one. Now let's apply that to this other problem. So I know that I have 1 to 1,000 inclusive. So that goes 1. It goes. Let's say that's 1, 2, 3, and then let's keep the last few numbers. Let's keep the last few numbers. 998, 999, 1000. So, or let's do this. 1, 2, 3, 997, 998, 999, and 1000. So here are my last few numbers, right? Okay. And then I have 1, 2, 3, and then I have if I have 1, 2, 3 like this, and I have, well, 996, or I only have 997, 998, right? I have something like this, okay? And for those of you who might be watching online, if I did it like this, so if I had, this is what everybody else is seeing on their screen, 1, 2, 3, ... 997, 998, 999, 1000. Okay, so I have 1, 2, 3, and the second set, I only have 997 and 998. Well, I can get rid of the 1, 2, 3, the 997, 998. What are the only two differences between the first one and the second one? 999 and 1000. All right, and the larger one, yeah, at the top is x. All right, so is the smaller one? Am I going to have to subtract? If I'm going from a big number to a smaller number, am I going to have to add or subtract? Subtract. So now, if I'm going to, what are the only two numbers left to subtract? 999 and 1000. So I'm going to subtract x minus 1999. Make sense? So that problem is then done. Okay? So let's move forward. We have next, if x is divided by 5, okay? I know you can see kind of the explanation for this. If you want to cover up the explanation that works just fine as well. Just but if x is divided by 5, the remainder is 4. If y is divided by 5, the remainder is 1. What is the remainder when x plus y is divided by 5? Well, how would I do this? So the first thing I would do is I would start by coming up with numbers for x and y. So if x is divided by 5, the remainder is 4. So give me a sample number of what this could be for x. If x is divided by 5, the remainder being 4. So on the next one, you see the one where it says if x is divided by 5, the remainder is 4. So give me an example of what number x could be.
29.
29. All right, now test day comes. You want to deal with a big number like 29? So let's go with a smaller number where I know that. So x could be, I'm going to say it's 9. It could be 29. It could be 19, right? It could be a bunch of different numbers, but I'm going to go with 9. All right, if x is divided by 5, then the remainder, if y is divided by 5, the remainder is 1. Well, what's the number that I can go with here?
X? I don't know.
6. Perfect. Okay. So what's the remainder when x plus y is divided by 5? Well, let's add x plus y. So I have x plus y. Well, what's x plus y equal to if I have 9 and 6? If I add 9 and 6, I get 15. Well, what's the remainder when it's divided by 5? 15 divided by 5 is what? 3. Okay. So what's the remainder? Is there a remainder?
No.
Okay, so we'll just put, what's the remainder? It's going to be 0. Okay? All right. Let's go with the next question. All right. For that, 1 second. Let me get my phone on a charger. Okay. So next question is the following. If P and Q, P plus Q, all right, and I know you can see the answer just based on how we printed the slides. So if you want to cover, all right, so if P plus Q is divisible by 13, which of the following is also divisible by 13? So what would I do there?
Question?
The next one. If P plus Q is divisible by 13, which of the following is also divisible by 13?
What page are we on?
So we just finished the one. All right, so if you just open your packet, first, second, all right, if you count, this is the first page, right? And the back is the second page. We're on 1, 2, 3, 4, 5, 6. We're on page 6.
What the problem is right here? 6?
Yeah, it says if P plus Q is divisible by 13, which of the following is also divisible by 13? You guys see that question?
Mm-hmm. And 6?
It's literally right after the problem that says if x is divided by 5. It's the second problem on the page. One, 2, 3, 4, 5, 6. All right, everybody good? So if P plus Q is divisible by 13, which of the following is also divisible by 13? So the best strategy here is to go through all of your answer choices. So pretty simple to do that. If I try let's try to work through P plus Q. So let's try two numbers that are going to, when added, are going to be divisible by 13. So let's try 20 and 6. So if I add 20 plus 6 together, I get 26, right? That's divisible by 13. So then, if I go through each, and with that, or I can even keep it smaller. Forget 20 and 6. If I try 7 and 6, right? So 7 plus 6, right, is equal to 13. Let me go through each answer choice and see which one that is. If I go through each answer choice and I get to C, I'm going to be able to see, hey, that's the right answer. This question is going to take you a little time. So when you actually see a question like this on the IACE or the SSAT, what you might want to do is star it and come back to it later, because it's going to take you quite a bit of time to get through the problem. All right? But I'm not going to go through and just go through every single answer choice. All right. All right. It's okay. So now I'm going to go to the next slide, where it says x plus 3 over 3 plus x is equal to 0. And it says, which of the following, for what value of x is the equation x plus 3 over 3 plus x equal to 0 true? At what point is this true? All right, does everybody see that question? Give me a thumbs up if you can see the question that I'm talking about. Okay, so now, really quickly, what happens when if I have 0 over 5, right? Suppose I have 0 over 5. What is 0 over 5 equal to? I think connection was weak, but if in case you're wondering, 0 over 5 is equal to 0. If I have 5 over 0, sorry, I couldn't hear you. 5 over 0 is undefined, or no solution. All right? Then the question then also becomes, well, what's 0 over 0? 0 over 0 is still undefined, okay? Any number, if the denominator is 0, then it's undefined. So let's go through my answer choices here, because a lot of people will choose A as their answer, because we can almost immediately eliminate B and C. Well, we can eliminate B because if I put in 0, right, 0 plus 3 is 3, 3 plus 0 is 3, that's equal to 1. So if I can eliminate B, then that means I can also eliminate C, because 0 is a real number, right? And it looks like if I put in 1, for example, 1 plus 3 is 4, 3 plus 1 is 4, 4 over 4 is equal to 1. It looks like pretty much every value I put in, I'm going to get 1 as my answer. But so let's try -3, because this makes it a little bit interesting. If I put in -3, I get -3 plus 3 over 3 plus -3. And that's going to be 0 over 0. Okay? Now, this is going to be an undefined answer. Anytime the denominator is 0, I'm going to get undefined. So that's still not equal to 0. So my last answer through the process of elimination is D. Does that make sense? Okay. So now, what I want you to do is try the next problem right, which is 3.5 plus 1.5 r is equal to r. So in parentheses, I'll read it again. Parentheses 3.5 plus 1.5, close parentheses, and then on the outside of parentheses, I have r is equal to r. All right, if you want to cover up the hint, you can. If you want to leave the hint there, that's fine as well. I'm going to, because I'm recording this, I'm going to delete the hint. Give me a little bit more space to write. All right, can someone walk me through the process of how I would do this problem? If I have 3.5 plus 1.5 r is equal to r, what am I going to do?
For R?
I heard solve for r. I'm not sure if I heard that correctly because I have a low connection for everyone. But the first thing I want to do is solve what's inside the parentheses. So I have 3.5 plus 1.5, close parentheses, r is equal to r. So I'm going to have 5r is equal to r. Okay, and if you want to just see that again, I'm going to have 3.5 plus 1.5 r is equal to r, and I have 5r equals to 1r. Does everybody see that? 5r is equal to 1r, and everybody understand how I got to that point?
Yeah.
Okay, so if I have,
Yeah.
I'm going to put this 1 in here. Now, a lot of people, what would you say the next step is to do? If I have 5r is equal to 1r.
Find possible.
Imani, say that again. So if I have 5r is equal to 1r, there's a few, well, would I divide to find for r? Would I divide?
No, it's no end and no solution.
That's incorrect. I wouldn't, it's not no solution. Because there's still variables, right? If it was 5 is equal to 1, then it would be no solution. But if I have 5r is equal to 1r, what I'm going to do is I'm going to get all the variables to one side. I wouldn't divide, I would subtract to get 1r to the other side. I'm going to get 4r is equal to 0. Let me see. I'm going to just show you this really quickly. Can you guys see that? So what I did is I brought the 1r to the other side. Does that make sense? All right. So I'm going to do this on the computer screen as well. Minus 1r minus 1r. I'm going to get 4r is equal to 0. Okay? So I'm going to get 4r is equal to 0. Then divided by 4, divided by 4. R is going to equal 0 here. All right? So the key here was really understanding how to do literal equations, or sorry, how to solve with variables on both sides, not literal equations. It was to solve with variables on both sides. Okay? It's just the same as if I had 2x plus 4 is equal to 4x plus 8. I would still get the variables onto one side, right? And I would do that by subtracting. Is there anyone who does not understand this problem? Because it comes up a lot.
So, like, equals 0, you would just, what happens then?
What did you say?
R equals 0?
R equals 0, right?
I know.
Right? Because, let's think about it. Because I got the 1r to the other side, right? And it was 4r is equal to, well, there was nothing left on the side, on the right side, right? So what number is there when there's nothing left on that side? 0. So if I have 4r is equal to 0, I divide by 4 on both sides. 0 over 4 just becomes 0. Okay? Okay. That problem, guys, I would really look over. It's pretty simple, but pops up quite a bit. Okay. Next problem. What is the value of the greatest of 4 consecutive integers if the greatest is 4 less than 1/2 the least? Okay? So if the greatest is, so let's set up the equation. All right? If I have, what is the value of the greatest of 4 consecutive integers if the greatest is 4 less than 1/2 the least? Well, what do I know here? I know that, what do I know about consecutive integers? If I have 4 consecutive integers, what are the, what's the smallest value going to be? Like, in terms of a variable. Let's call that x. All right? If my smallest value is x, then what's the next value going to be?
X plus 1.
X plus 1.
X plus 1.
And then x plus 2. And then what's the last one going to be?
Plus 3.
X plus 3. Great job, guys. So now, if I have, all right, and try not to look at the slide with the answer on it. I know you guys can because I gave you the handout, but let's try not to look at it. All right, so now I know that if the greatest is 4 less than 1/2 the least, well, the greatest is what? X plus 1, x plus 2, or x plus 3? X plus 3. So I know x plus 3 is equal to, it says 4 less than 1/2 of the least. Well, what's the equation for 4 less than 1/2 the least?
X minus 4. Are you yelling?
Perfect. 1/2 x minus 4. All right, and then you can solve this, right? Does everybody know how to solve this? All right, in case you don't, I'm going to do a quick solve. I'm going to do 1x plus 3 is equal to 1/2 x minus 4. All right, I'm going to make this minus 1/2 x. I'm going to make 1x into 2 over 2x minus 1/2 x plus 3 is equal to 4. I have 1/2 x plus 3 is equal to 4. And then I'm going to subtract 3 from both sides. And you can see this on the slide with the answer key on it if you want to see what that looks like. And, sorry, this is going to be negative 4. You're going to have 1/2 x is equal to negative 7. And you are going to get negative 14. So if you're going to multiply this by 2, multiply by 2, x is equal to negative 14. If you, and for those of you who are going to see this online later, if you want to see what that actual process looks like and not in terrible handwriting, it's right there. And for those of you at home, you can see that on your slides. All right, so we have x plus 1, x plus 2, x plus 3 equation. X plus 3 equals 1/2 x minus 4. You can kind of go from there. Once you've set up the equation, it should be pretty simple after that. All right. Let's try this Annie and Billy question. Annie knows that y is an integer greater than 3 and less than 12. Billy knows that y is an integer greater than 6 and less than 14. Then they know y must be, all right, what? Okay, so Annie knows that y is an integer greater than 3 and less than 12. All right, Billy knows that y is an integer greater than 3 and less than 14. Then they know y must be. All right, this is a pretty simple question. All right, I'm actually going to have you guys look at your answer key for this one because it's pretty simple. All right, what you would do for this problem is simply list out your integers: 3, 4, 5, 6, 7, 8, 9, 10, all the way through 14. And the reason for that is that I know it has to be between 3 and 14. And I'm going to eliminate anything that's not possible. Well, if it's greater than 3 and less than 12, all right, and Billy knows that it's an integer greater than 6 and less than 14, all right, I can eliminate 3, 4, 5, and 6. And it's going to be less than 14, so I can eliminate 14. And I know it has to be less than 12, so I can eliminate 12 and 13. So the only numbers that are left are 7, 8, 9, 10, and 11. Alright? So you have those 5 possible values. Any questions on this one? This one was a pretty simple problem. You just had to kind of go through it. Alright. So I didn't even realize that there were page numbers at the bottom of these slides. Alright, if you look at, we have page 8. How do you guys feel about these absolute value equations? I think you went over those with Miss Brown. You guys are pretty comfortable with that. I can just skip that, correct? Okay. I do want to go over the not the first one, but the second one. All right, the second one is very, very important. I want you guys to write down this formula, and you need to have this formula forever. Okay.
Okay.
So, if given a graph, and I'm sorry the answer is already circled for you, but if you're given a graph and you have an absolute value, all right, and if you have a number line, they give you a graph, right? And they say find the absolute value equation. The formula for doing that is always going to be the absolute value of x minus distance. All right, close the absolute value sign, is equal to the average. Okay, so I'm gonna write that on a paper so you can read that as well. I think Miss Brown went over this with you, but in case she didn't, here's that. The absolute value of x minus distance is equal to the average. Does that make sense? Or can you see that?
Yeah, I can't see that.
Purple.
Yeah, everyone's is purple for mine too. So it's the absolute value of x minus distance is equal to average. Okay, so now what I'm going to do from there is I'm going to then go do x. Well, I'm going to find, well, what's the average of those two numbers? If I have 6 and negative 2, how do I find the average of 6 and negative 2?
Then divide by 2.
Okay, so I'm going to... Yep, so I'm going to add these two numbers. I'm going to do 6 plus negative 2, and that's going to give me 4, right? Does that make sense? And then I'm going to divide that by 2, right? So I have x minus distance is equal to 2. Does that make sense? Because that was the average, all right? And I'm looking at the average between those two numbers, okay? So I have a mark right there. Well, what's the distance from the average number? What's the distance on either side? Well, we can go 1, 2, 3, 4. Oh. Guys, I'm sorry, I made a huge mistake. The formula, sorry, is not x minus distance equals average. It's what? X minus average equals distance. I apologize about that. Wasn't thinking for a second. So let's rewrite this. X minus average equals distance. Okay. Distance. Okay. So let's go over this one more time because I made a huge mistake. I do apologize about that. So the distance, the average between those two numbers, right, was 6 plus negative 2, and that's 4. And then I had 4 divided by 2, which is what? 2. So then I have x minus 2 is equal to, well, if I look at the number line, if I start at 2 and I'm trying to get to 6, how many am I away? If I start at 2 and I'm trying to get to 6, how many am I away?
4.
4. All right, so I'm 4 away. So x minus 2 is equal to 4. All right, and the x minus 2 is in the absolute value sign. All right, does that make sense? Is that starting to make a little bit more sense, guys? All right, let's do another one like that. All right, and I'm going to show you because this isn't on there. If I gave you a number line with let's say negative 4 and okay. Okay, if I gave you a number line that looked like this, negative 4 to 0, okay? If I gave you a number line that had negative 4 to 0 on it, and those are my 2 points, I have one at negative 4 and one at 0. Well, what's my formula again? It's x minus average equals distance. All right, I'm going to draw this number line on this online piece as well. So if I have a new number line and it's negative 4, 0, I have point here, I'm going to connect these. I have negative 3, negative 2, negative 1 in the middle. Well, what is the average for that if I have negative 4 and 0?
Did you write it down on paper? I couldn't see it.
All right, sorry. If you can't see it, do you guys see that now? Well, if you just need me to describe it, it's essentially just negative 4, negative 3, negative 2, negative 1, and 0 on a number line. And it's going from, the points are going from negative 4 all the way to 0. All right, everybody see that? Okay, so I'm going to ask you guys to solve that problem. And then if you can, show me your answer when you get it. So remember, you should have x minus average equals distance. All right, so if I have, what's the average? I can't hear you.
Negative 2.
Negative 2. So my value, so it's going to be x minus negative 2. So if I have x minus negative 2, that's going to be the same thing as what?
X plus 2.
So I have the absolute value of x plus 2 is equal to, what's the distance again? What's the distance from negative 2?
2.
2, right? Because to get from 0 to negative 2 is 2, and then to get from negative 4 to negative 2 is also 2. All right, so I'm going to end us there for now. We'll pick up again on Friday. In the meantime, all right, so I'll see you guys tomorrow. Make sure you're there tomorrow, because tomorrow we'll be working on some application stuff to high school, and you're not going to want to miss that.